So, hello, my name is Jan Hoth. I'm support engineer at Tasking. Today, we will have a session about the TriCore and the startup initialization. We'll first have a look at the TriCore manual to have a look at what we actually need to initialize. And that is quite a lot. Let me just pull out the manual. There we go. There's quite a lot going on the TriCore. You will have to start the clocking system and some other things like the cores that you want to operate. So that is all done by the startup code. And in order to get there, the tasking toolset has quite a few options that allow you to control the startup behavior. The most important thing that you will have to look into is that you get the core 0 to initialize the other cores if you want to run them. And also if you want to influence the clocking of the chip, like we see here in the user manual of the TriCore. This is a TC3X RX2G second generation manual for the TC39, 37, and so forth. And as you can see here, we have the clocking system. This clocking system consists of a layered structure where you have, for instance, an external clock source, which can be a resonator or a crystal with some capacitors, which provides the external clock reference to an internal oscillator inside the chip. And usually this is a lower frequency in the range of 20 megahertz or so, which is usually being used for these chips, 20 megahertz as external crystal. And the reason why you don't use 300 megahertz or such a high clocking, of course, is EMI reduction. So if you have a lower external frequency that toggles the lines, you have a lot less EMI. And that's why Infineon has chosen to use a low speed or comparatively low speed external clock and then multiply that crystal frequency inside the chip. So the next step which we have is the clock upscaling. And this clock upscaling is done with a PLL unit, which we can see here. And that PLL unit is not static, but it can be influenced, and you can use multipliers in order to determine which clock speed you have internally in the TriCore. So that's not a static thing. There is no given fixed relation of the external clock and the internal clock. You have the possibility to influence the clock frequency over a relatively large range. And that upscaling is a bit complicated. If you look at the manual, I'm not going into the details here because there's a lot of multipliers and values that need to be calculated. If you want to do that manually and get it right, you'll sit there for a while and do your calculations in order to get the right internal clock speed. The next thing, which is a bit unusual compared to other processors or older processors, is that you do not have one overall system clock speed for all the peripherals, which then use this clock speed, but you can distribute the clock speed, which is the main clock speed here from the PLL, via a CCU a clock distribution unit. And this clock distribution unit allows you to set individual clock speeds for individual peripherals. Say you want to use the Ethernet unit, which you want to operate at the maximum speed. Then you want to use the system timer, which you want to use maybe as a slower long-term clock. Then you can assign a higher clock speed to your Ethernet unit and a lower clock speed to the STM system timer, for instance. And that goes for all other peripherals. There are quite a few clocks, that subclocks, that you can control. We will see this later if we go into the configuration menu. And basically, what you can do here is use one external clock source, multiply it up to one main clock, and then distribute several subclocks to the individual peripheral units. The GTM is one of them. The timer units are one of them. As you can see, the CAN unit is one of them. So if you want to use CAN at a specific clocking, you don't have to mess around with the CAN unit and do a lot of dividing and calculate the timing of the CAN unit, as it used to be with older processors. But you simply assign the CAN unit a specific clocking value that allows you to get the right CAN communication speed. And likewise, you can do the same with the serial ASC unit. For serial and SPI data transfer, you will usually want to clock down or divide the clock down for the ASC unit, because the transmission speeds usually are quite low compared to other peripherals that you want to use. PWM, you want maybe to have some high speed. Well, anyways, the CCU allows you to distribute the clocks of the speed, and the process involved in that is rather complicated. As you can see, there's a whole bunch of registers here that you need to be set to control the clock speed. And if you go further down in the manual, you will see that there are quite some nice formulas and values to be applied. So the whole thing is a bit complicated. So Tasking has decided to take this tedious work off your desk and allow you to configure the processor using the Tasking IDE, where basic settings are being made in the startup code. I've already prepared a little sample for you, but just to make sure that you can use all the settings that you make in the menu, you need to go through specific steps when setting up a project in order to actually get a useful result. So I'm just going to create a small dummy project to guide you through the steps here. The first thing is you create a new TriCore C++ project. We just call this dummy because I have already set up another project where I can show you around. And then we choose a Hello World C project because we have a little bit of code in there. It's not going to be an empty project. Let's start up. By the way, if you have any questions, feel free to enter them in the chat. We may have some time to control this afterwards. When we're finished with the session and have some time left over, I may be able to answer some of them. So first step, create a project. You can create an empty project and later add your own source code to this. We will choose to just make a hello dummy project with a little bit of a hello world code in there, so we don't have an empty main. Then we will select the chip family. As you can see, you have a large selection of chips that you can use. The Aurix family is the TC2 series, and the Aurix 2G is the TC3 series. For what it's worth, we're just going to select the TC39. It's got a lot of peripherals in there, and you can control a lot of things. And I think that is a good example to show you what you control, what you can all control using the Tasking IDE menus. Please note that these boxes must be checked to add the startup code and also add the linker scripts. And if you want to debug on hardware, also add the debugger synchronization utilities. Do not leave these out unless you have your own startup code or some custom code that you want to use. Otherwise, we're just going through the default project generation and creation and make sure this way that we have everything in there to get our project set up properly. So the next step is to select the debug options. There are a couple of items here I want to mention. If you want to debug on hardware, which is normally the standard use case, you have a variety of boards here, TC37, 39, application kit TC39. And what's important, you also have a configuration for the debugger. Normally, the PLL clock for safety reasons is set to a very low speed. I think it's about 500 megahertz for the JTAG clock speed. But for the TC39 and all RX 1G, which is the TC2X series, you can safely select 10 megahertz, which is then the JTAG speed. And the debugger assumes 300 megahertz. Which is also the default frequency that is used on startup. If you do not play around with your PLL, debugger will assume 300 megahertz, and the chip will also start with 300 megahertz internal PLL frequency, because these are the default values which the chip uses when it starts up from a cold start and you do not perform any extra initialization for the PLL. But 10 or 20 megahertz with the TC 30, 39, 37, and so forth are usually a good value, which gives you a little bit more responsive debug communication and also flashing and uploading to the target. So for this sample, we're just going to use the instruction set simulator. It's a dummy sample, so we're not going to fire up any hardware. Okay. So we've got this project set here. Now, you select the properties. You will select this item quite often, and then you have the startup configuration. There are two items that you will want to use to influence your startup configuration. The first item here, as you can see, you can set a whole bunch of different items here. Most important, if you run a multi-core application and you also want to trigger the operation of the core 1 and core 2, you can enable this by ticking start TC1, TC2, TC3. As we have selected a TC39, it has 5 cores. But just for an example, if you want to run code and activate core 1 and core 2 and the other cores, you need to tick this, because the startup code will then kick these cores to be operating. Otherwise, they're just being left alone and they're going to do nothing. This is, by the way, one of the complaints that happens is that people come up with questions and they say, "Oh, my target is only running on core 0, but core 1 and core 2 are dead. They're doing nothing." Well, if you have third-party software, you need to dig around in your code and set macros or write extra code for it. With the Tasking IDE, this is all part of the startup code that will enable you to start the cores 1, 2, 3, and whatever else you have there. There are some other settings, like the safety watchdog enable or safety watchdog disable and so forth. These items are all filled in with default values, which you can leave, But if you have any special requirements, you should look over these options here, because before having to write a bunch of code, you rather want to set this using the IDE, because it's already in the startup code and then being enabled with a header file. We'll have a look at that. The same goes for the core 1, core 2, core 3, and so forth. Whichever number of cores you have for that specific selected processor, you will have the items here in the tabs of the menu, allowing you to select individual settings for each core. Of course, you have to coordinate this. What you need to know is that upon cold start or any start condition, usually core 0 is the one with the most responsibility. It will automatically run and then do the initialization for the other cores and whatever is necessary to run the complete chip. So core 0 basically has sort of a lead function here. This is what you need to keep in mind. The next item that we are going to look at is the startup registers. And here we come to the point that we have quite a few registers that you can influence, like the CSFRs, the bus control registers, the external bus units. So you don't really have to fiddle around in your source code with a lot of macros and write this stuff yourself, but this is actually done in the startup code, where you can set specific address select registers for the external bus unit and so forth. The GTM also has a clock control register which you can influence. Other than that, there's not much for the GTM. There's quite a bit. There are a few ports which you can influence, and then we have the system control unit, which does have a significant influence on the chip's behavior, because this is the place where you can, you may already see it. You have here the CCU, the sys PLL con, which is the PLL control register, and the peripheral configuration registers. And these are the registers that we have just seen previously at the beginning, which are listed in the RX user guide, Infineon user guide for the chip, and which are really complicated to operate if you want to do it manually, because you have to deal with a lot of values and constants and do some multiplications, and or if you want to do that first attempt, you usually get it wrong, unless you are very proficient with the units and also with the methods to initialize them. So the PLL control register basically allows you here to set the dividers and the values that you can use as the clock source. Same thing with the PLL control register 1, where you set the K2 divider, the infamous K2 divider. If you want to know what that is, just have a look at the chapter 10 of the RX user guide, and you will see what K2 is about. It's a lot of fun if you want to do that manually. And if you want to set anything, don't forget to also tick this box if you want to set a specific value, initialize in startup code. If you don't do it, you make your settings, but it's not going to end up in the startup code. So here we have the CCU, which we could see in the user guide. So we are in this part here now, which is the clock distribution. The clock speed upscaling, which is the PLL, is covered in the sys PLL con, which is the system PLL control registers. Then we also have peripheral control registers. The nice thing is that if you are in doubt about the actual speed of especially the RX 2G. And if you don't really know what you have actually set, the TC39 and the TC3 series offers 2 pins named X clock. And these are actually external clocking pins, which allow you to put the internal frequency with a divider to an external port pin. So if you have 300 megahertz internally, you have a divider and divide it by 12 or by 10, or let's say 10, then you'll end up with a 20 megahertz, 30 megahertz signal on that pin. And if you have a scope, like a smart scope, USB scope or something like this that can cover digital signals or that has a frequency counter, you should be able to figure out what frequency you actually have inside if you're really in doubt. Because otherwise, trying to use a method using counters and other stuff will usually end up in time-consuming coding, and then you end up with wasting a lot of time wondering what frequency you're actually running. Yeah? But to avoid this situation, as I said, you have these menus here that allow you to have great control over what you're actually doing. Now, the CCU clock control register 0, as you can see here, allows you to set a clock for the general system timer, the STM, and for the GTM. Then CCU clock allows you to set the CCU clock register 1 allows you to set the CAN divider, the QSPI, and so forth. And you basically have quite a lot of selections here that you can make for your peripherals. You can see it here if you want to divide the clock source down for CAN, just to slow the CAN down. You have various options here to use a 10th or an 1/8 of the frequency, depending on what internal frequency you're actually using. So, and don't forget to set the initialize and startup. So I think, were there any comments? If you have any questions that I said, you can show them in the chat. I just have to see if there's any chat questions here. No. So we are just going to use maybe the CCU clock control register and initialize the stuff just with default values. And now we will have a look at what consequences this actually has, because the mechanism behind it, once you have understood it, it's easy to understand. You have cstart.c, which is the startup code, and you have the header file. And the header file is actually the one that controls the whole operation of the startup code, because this is where your settings, which you've done using the startup settings menu and the startup register menus, this is where it actually ends up. As you can see, I have selected to start the core 1. I have selected to start the core 2. And this is actually reflected here by being set to a value of 1. And later, here in the startup code, you will see that this macro is actually a conditional. Which is being used later. Somewhere down the line, I have to find it. But you see that there are quite a few macros, and these are being used or expanded as soon as you have set something in the header file using the menus. Now I'm trying to get hold of the chat. As I could see, there were some questions. Oops. So yeah, I could see there were some questions. The webinar last week, there are recordings of the webinar, and we will make these available. So if you want to actually watch the webinar, I would recommend that you just send an email to support@tasking.com, and then we can provide you with the information when the recorded webinars are available. So what does the output look like? How does this align with AutoSAR, MCAL, drivers and configurations? Well, quite frankly, this depends on what kind of startup code you're using. If you're using a third-party AutoSAR implementation, the third-party vendor will usually provide their own startup code, and then you will likely have to follow the instructions of that vendor as how to influence your startup behavior. If they choose to use the tasking startup code, you're fine. You can use these project settings, but other than that, you will have to use the vendor-specific configuration tool. But because from what I could see in samples from customers where support questions were on the line with regards to settings, configurations, and so forth, I have a very strong impression that all vendors of AutoSAR units, also, for instance, MCAL from Infineon, have their very own technique. They have their very own startup code, and configuration of that startup code and that behavior is then done with whatever configuration tooling you have available from that vendor. With Infineon, say ILLD or MCAL, you will likely have to use hand coding for that. So we currently do not have a feature enabled or a feature implemented in our compiler to actually use or generate AutoSAR specific code. But well, that's a good question. We'll pick up on that, and it might be something we can discuss internally if we could offer this as a feature of future tasking products. So are there any new questions? I just see like 3 or 4. Can I generate makefiles automatically for my project? Well, the makefiles are being generated by Eclipse, and you can use them anytime. As soon as you have configured your project, you can go to the command line and run the AMK, the tasking make tool, AMK all or AMK clean. The makefiles are all in place, and you can also use these makefiles on the command line and execute them. No problem with that. Eclipse does generate makefiles, but for the startup behavior, the makefiles are not relevant. It is what you do here in the IDE, which then ends up in the startup header file. If you have an own project where you want to use this particular startup code, you can also take it and copy it into your own code repository, and then you have a functioning startup configuration, whichever way you want. So, any more questions? is there a guide available for for the tasking startup configuration? No, I'm just doing a video about it, and you will be able to see that video in our webinar series. Other than that, there is a startup guide for using the tasking toolchain. There's not only a user manual, but also a getting started manual that shows you how to get started with tasking toolset overall. Now that's part of the documentation. Let me just have a look here. And it is, I hope you can get my screen, getting started. So that's the getting started document. I hope you can see my content here. There's quite a few chapters in here: preparing for first use, installation, and then also how to set up a project. Configuring the target is in chapter 3. That's mainly for the board configuration, as I've shown you in the beginning. There's quite a few project options. The startup behavior is a little bit sidelined. These are the major options that you can use. And then the startup behavior on the startup configuration is a bit of a special setting that if you want to go into more details, which you can use. And that's what I just explained to you. How can I build the software with our custom make system? From Srinivas. Well, you can use the makefiles that Eclipse has generated. It should be possible that if you have a custom make system, you can use makefiles that are already there. So whether you use AMK, which is a rather simple tasking parallel make, AMK, or MKTC, which is a relatively simple make utility, I'm sure you can also use another make as the language of the tasking make utility is comparatively simple. So that should work with any make utility you have. So from Haitam, there's another question. Can the order of these configurations be also selected by the tools, as some functions may depend on others? Does this startup configuration include communication such as SPI or CAN? No. It just sets the peripherals. It sets up your SPI clocking speed, and it sets up your CAN clocking speed, and initializes the CAN unit. But that's about all you have. Any software, low-level drivers, and anything on top of the bare the bare bones initialization of the hardware, you need to have that on top of that. We used to have a software platform. You can use it, for instance, if you have ILLD code from the Infineon low-level drivers. You can use that particular. You can use the configuration with the tasking startup code to along with your Infineon low-level drivers. I've tried it, it works. So from Srinivas, how to integrate our custom make system to tasking GUI and build from tasking GUI? That's a different question. You can integrate your build system if you use an external builder, for instance, and then you have to define an external builder. But that's a bit of a question that doesn't really apply to our startup settings here. But I'm just going to show you around. Eclipse allows to use internal builders and external builders and so forth. If you look at this, you have an external builder, you have an internal builder, and basically you need to figure out what kind of a builder you want to use. You can configure this in Eclipse. Yeah. I hope this answers your question with regards to integrate your custom make system. to the tasking GUI. Yeah. So you have the options to use an external make, or you have the options to use a command line make, as the make files are already there. And if you want to use a different build system, you will have to define sort of an external builder for Eclipse in order to use it. No, there are some external builders, but to be quite honest, I haven't played around with them much because there's currently no need within tasking support to try any external builders unless there is a customer use case. So we're already 5 minutes behind schedule. If there's any questions, I'll be happy to answer one more question if you have any. Otherwise, I say thank you for your interest in our product and into the subject. I hope the information was useful for you to get started, especially with the startup behavior of the Tricore. And I hope to see you soon for another webinar, because we still have a little bit of stuff coming. Thanks a lot for visiting, and bye.